And welcome everybody to the Daily Space Weather. I'm your host Dan, aka smAsho. There's a geomagnetic storm in the offing. It's expected to come tonight, just before midnight Universal Time. Yes, a geomagnetic storm. Are you scared and spooked yet? Well, you shouldn't be. It's going to be pretty minor. And if it does cause any power disruptions, they'll be likely to only occur in places with very bad power grids to begin with. So, welcome Stargazers. We'll be talking hydrogen nuclei headed to the geospace near you. And there's a new show segment, the Smash Hole of the Week. We'll talk about it. First, we'll look at the sun. And lots of filamentary activity going on. There are still some major plasma filaments between Earth and Sun, and there still could be additional coronal mass ejections. Yes, we're able to forecast them without respect to things like solar flares and sunspots, as they happen without sunspots and solar flares present on the solar disk regularly. Part of the reason why we make a channel. So here's the view from Lagrange point 5. The next slide here will show you the coronagraph from stereo A, as the SDO is located between the Earth and the Sun in a semi-geosynchronous orbit. Here's the view from Lagrange point 5. So the Earth would be out in this direction. And you can see that's Venus, I believe, just leaving the frame there on the left side. So there is still significant possibility of coronal mass ejections in the sort of the Earth-facing vicinity. So don't be surprised to see that. We'll cover it if it happens. Again, that's the viewpoint from stereo A out at Lagrange point 5. The radio flux in the 10.7 centimeter, or you could say 2800 megahertz variety, is all the way down to 78. So quite low levels of radio flux. There's the 1-year chart of that. Allow me to vanish. There you can see a radio flux now down below 80, having reached well into the 100 teens during the last flurry of solar activity. Again, still a whole bunch of plasma on the surface. And here I just brought up the historic chart, and you can see how low the radio flux is right now. It's all the way down to around this level. So there you can see the last several solar cycles there, going all the way back to 1947, when it was initially discovered by some Canadians using World War II radio equipment to realize that the sun was outputting a specific frequency, 2800 megahertz, or 10.7 centimeters. So here's another view of the local yellow dwarf here in 171 angstroms, one of the ionized states of ultra-hot iron. And you can see a bunch of filaments in this wavelength as well. And let's move on to some more detailed stuff here at helioviewer.org. Here's one of our HelioViewer movies. HelioViewer movies. Here's me learning to speak English. Anyway, there's a view of the LASCO C3, which is the blue, the LASCO C2, which is the red ring, and SDO, the Solar Dynamics Observatory imagery of the sun in 304 angstroms, which is ionized helium emission spectra. And here's a view in 335 angstroms. We'll show you more multi-wavelength views of the sun here at the end of the video. First, there's a whole bunch of other information to talk about, because here at the Smash News Network, we prefer to be comprehensive. So, like I said, there's going to be a new segment coming, and it's not just going to be Smash Lights. It's going to be Smash Hole of the Week. It's going to be a new segment, Smash Hole of the Week. If you've got ideas about who or what entity or whatever should be the smash hole of the week, leave us a comment. Let us know what you think. And we're having a tough time deciding who will be the kickoff of Smash Hole of the Week. But let me just define a term for you, since we have a defined terms defined playlist. Let's talk about covidiots. Covidiots, it will be a noun, a disparaging noun, talking about people making a pathetic and ineffective and indeed harmful series of decisions to respond to coronavirus in a futile attempt to control a virus. To use it in a sentence, holy cripes. Covidiots expect asymptomatic people to wear a mask despite their lack of symptoms. I won't go any more in depth into it, but hey, why don't you follow us on Twitter? It's twitter.com/smAshomash. Don't have a hissy fit if there are political posts. All right, in any case, thanks to our Twitch followers. We are streaming live currently to Twitch, twitch.tv/smAshomash. It's such a good platform. We use it regularly. We also stream live to YouTube, and we've got a bunch of playlists over there, youtube.com/smAshomash. Please take a moment to press like and subscribe. Visit our links, become a patron, etc. Get involved. Take a towel, throw it up in the air. When it comes down, the towel's brown. Wash the towel, get the brown into the ocean, get all the brown from the ocean back into the air. Eventually, recycle pollution. It's important. It's crucial. I don't know who gets the writing credit for that, but cheers. youtube.com/smAshomash. We're also on BitChute. Look for a special coming there soon, thanks to our BitChute subscribers, new and old. We've just reached 300. And this brings me to the Cosmology segment. Now, we don't always do Cosmology segments. And stop asking me if I want to buy followers on Twitch, because that gets you a 6-minute timeout. 10-minute timeout, actually. No, I don't want to buy followers or viewers. All right, so let's go to cosmology here. We're going to roll a 1,031-sided die. Oh, and I remind you, don't forget to check out the Smash Holes Smash Hole of the Week segment. And before we do cosmology, thanks patrons. We've got the new list up here. Patreon.com/smAshomash if you'd like to support the channel. There's all kinds of behind-the-scenes stuff and other freebies for our patrons at patreon.com/smAshomash. And for you patrons who are still at the $1 or $2 per month levels, please upgrade to the $3 or more per month levels, as you're not getting any benefits at $1 or $2 per month anymore. Next, I want to talk coronal holes. Were you aware that coronal holes give us important insights into the sun's magnetic field behavior? Yes, it's true, folks. The behavior of coronal holes throughout solar cycles is very important. Now, this is a recurrent one, which was on the sun for nearly 2 years. Something like 50 Carrington rotations. That coronal hole remained there back in the years of 2006 and 2007. If you want to read about coronal holes, well, don't worry, we're going to do a video about them. But if you want to research coronal holes yourself, there's a great list at solon.info/solar coronal hole history since October 2002. So the one we were just looking at there is this recurrent one. This was from more like 2006. And this was geoeffective many, many times. So this caused multiple periods of geomagnetic unrest, such as this 582 kilometer per second solar wind and a KP of 5. So a minor geomagnetic storm, which is actually what is forecasted from the coronal mass ejection that's striking now, by the way. So yeah, let's roll a 1,031-sided die and see what number we get. Today's number is 516. Now, yesterday we talked about a gamma ray burster, which we unexpectedly saw there. Today we're going to 516. And 516 is a low mass X-ray binary / quote black hole, end quote, known as 4U1543-47. So there's the historic X-ray output from that object going back to 2005, it looks like. And there's the recent, you can see this is day of the year here. So there's day 365. That's the recent X-ray output from that galaxy. I mean, not galaxy. Low mass X-ray binary / quote black hole, end quote. And here this object is on Aladdin Light. Again, that's 4U 1543. And if you put in 4U 1543, you should see it. I'll bet you this one shows up on Chandra. And you can see it's got a bit of an irregular shape there, something you'd see regularly with low mass X-ray binaries. In this case, the crosshair is probably on the massive radio source and not the white dwarf, which is most likely what that is. Here's the Chandra. And we're not seeing anything on the Chandra. How about the Fermi? Does it show up as a gamma ray burster? And indeed, it does not. So let's see if we can see it on the 2 mass. It's regular to see this stuff in infrared. And there's a great view in infrared of the massive radio source. We'll just call it a massive radio source, also known as VL, whatever that was. I prefer to call it 4U 1543-47, a catchy name for that low mass X-ray binary / quote black hole, end quote. So here's just another follow-up here. This is the object we looked at yesterday, HT 19001. HT 1900, you could call it. HT 1900 is a good name for that one. That was indeed a gamma ray burster that we stumbled upon in yesterday's Cosmology segment. If you want to read more about that, you can find it, HT 1900. You'll find it if you type in that and gamma ray. And that's the Cosmology segment today. We don't want it to be too long. It's just a portion of the daily space weather, as these things do affect the rest of cosmology. And since the sun is the Rosetta Stone of cosmology, if we don't understand how the sun works, we certainly don't understand the rest of cosmology, as it's all based on, including geology, based on the way solar systems form, isn't it? All right, in any case, here is the real-time solar wind information, and we just saw an uptick to around 11 protons per cubic centimeter, and that'll show up on the magnetosphere movie on the next frame. Solar wind density. So solar wind density around 11 protons per cubic centimeter, solar wind speed around 300 kilometers a second. And we just saw an increase and then a decrease in that. So you saw the temperature. That looks like a little pulse from a coronal mass ejection there, folks. So that most assuredly is a little pulse there, nothing to really be concerned with. And it probably didn't even have any effect on the total fields or anything like that. Let's talk about Bremsstrahlung for a quick moment. If you're not familiar with Bremsstrahlung, Bremsstrahlung is a reference to breaking radiation. So when solar protons strike the magnetosphere and they come in contact with electrons especially, also the breaking of the electrons themselves produce electromagnetic radiation. So when that happens, such as when a cosmic ray strikes the atmosphere or when a proton strikes the magnetosphere, you see a situation of Bremsstrahlung happen at that moment. There's basically no translation. It simply means breaking radiation from a thing that would occur in like at CERN, or from synchrotron radiation, from electrons circling the poloidal field or the toroidal field of a massive radio source. Bremsstrahlung. It's basically no translation, and it makes me glad I took German, because I can almost pronounce it. Next, we'll look at the KP index, which is currently only at 1, seeing pretty weak magnetosphere information right now. So here's the magnetosphere over the past 4 hours. It's a visualization based on the space weather modeling framework. So you're looking at the magnetohydrodynamic pressure here in nanopascals, and there you can see it drop off. And then at the end of the video, you'll see it come back up. And since it refreshed, we'll let it play through. And if you're wondering what's in my coffee, it's cayenne and cocoa. And here at the end, you should see this pop back up as the solar wind speed pops back up. You see a pretty equalized magnetohydrodynamic pressure here in both the bow shock and the magnetotail region there at the end. Here is ground magnetic perturbations. These are changes in the Earth's own internal B field as measured on the Earth's surface. Keep in mind, like the last movie, this is indeed a model. It's showing us where we would expect to see changes in the B field. And since we're currently involved in a geomagnetic excursion, where the south geomagnetic pole is somewhere down here, south of Australia, and the north magnetic pole is someplace over here, because there are two of them. There's one over here over Siberia, and one over here over northern Canada, which makes for quite a different environment. We also see weak spots down here and over here, known as the South Atlantic and I guess the South African anomalies. So, we don't see any spikes in the proton flux here. I wouldn't expect to see a spike in the proton flux, as this is the GOES 16 greater than 10 mega electron volt proton flux. But if we do see it, we'll definitely report on it. We haven't seen one since some more serious coronal mass ejections. We actually saw 2 spikes in this in the current solar cycle. It's one of the more important factors, the greater than 10 mega electron volt, greater than 50, and greater than 100 mega electron volt proton flux. Here's the X-ray flux. No major flares over the past 3 days, or the past couple of weeks for that matter. And the GOES magnetometer is pretty spiky here. See these spiky patterns. It's kind of all over the place. And let's get a closer look at what's going on with the magnetism with the top view ecliptic plane field plot, which is part of the National Sunspot Observatory. It's what we like to call the Gong 2 data, and this is probably the most important one. And as I forecasted yesterday, the Earth is still in the South Pole-oriented current sheet. There is a little bit of activity on the sun right now. It's in the form of coronal holes. We'll show you on the next slide. No forecast as to whether we'll be in the North Pole current sheet or not tomorrow. It looks like there might be some activity north of the equator, if I had to guess. So, if we see something like a sunspot forming north of the equator, don't be surprised. That's my going out on a limb forecast. Here's the coronal hole field plot. It also shows you the B field in blue. And you can see significant trans-equatorial coronal hole there in red. It's South Pole oriented. And here's another view of the same thing here, looking at also the solar magnetogram. And you can see the poloidal fields there as well. And lastly, we'll look at the fields of just the corona, or an attempt to look at them. And when you're looking directly at the sun, this is quite a view. The corona is quite a chaotic environment, so even trying to calculate where these lines should go is indeed impressive. It shows you open potential field surface source lines in purple or black if they're at the poles or if they're more close to the equator. And it'll show you closed potential field surface source lines in pink. It's pure chaos. Here's what's going on in the sky above my head. I like to use in-the-sky.org. And we've actually got the galactic plane and the ecliptic plane, which is the plane on which planets like you rotate. And the moon basically follows the ecliptic plane also. And if you think the moon is upside down because you're in the southern hemisphere, you are crazy. Yes, the moon appears upside down. And you see a full moon at noontime on the opposite side of the Earth, by the way. Here on the Pennsylvania side of the planet, we see full moons around midnight. And on the China side of the planet, you see full moons around noon. Why? Because the moon gives you insight into where you are on the planet. Just a quick little piece of info there for all of you people who think when you're seeing a photograph of the moon that it's the moon is flipped upside down because I'm seeing a photograph from somebody from Australia. Oh noes. Anyway, there's where stuff is located in the solar system. There's where things will be in a week. Approaching a new moon, my favorite phase. As people get the best sleep around new moon, make sure your sleeping chamber, SMAsho tip, make sure your sleeping chamber is very dark, folks. If your sleeping chamber isn't very dark, it's not good enough to just wear a blindfold. Your skin has sensors on the surface of your skin that know if it's dark or light in the room in which you're sleeping. And so, yeah, it's pretty serious. Next, we'll talk electrons. We don't see charging hazards. Here's a 1-year chart, and we see pretty low levels of electron flux, and even lower levels forecasted for when the coronal mass ejection strikes, which is again forecasted for late tonight, early tomorrow. And we're talking in universal time here, so midnight universal time is 7 p.m. here in eastern Pennsylvania. The Eastern Time Zone, New York City, the New York Time Zone. You're talking 7 p.m. Actually, it's more like, I'll say 6 p.m. is when the strike is forecasted. And it's expected to cause a minor geomagnetic storm, a G1, a KP of 5. KP index expected to be at 5. So here's the electron flux over the past 3 days. We see quite low levels here. And here is a visualization of the electron content. It's the electron content forecast. And this will give you ideas of where we would expect to see GPS errors, for example. Here's a diagram in miles of where things like the Solar Dynamics Observatory, the International Space Station, the Van Allen probes. Again, keep in mind it's in miles. Here's another diagram which is in kilometers, showing you things like penetration of electromagnetic radiation. And the F ionosphere layer shown there on the right, that is in kilometers. And that image is courtesy of NASA.gov, which is why I don't need to give a credit. I gave taxpayer dollars for decades. Here is the F ionosphere layer. Now we're just looking at just the F layer of the ionosphere, folks, as this is where some interesting activity behaves. And we see anomalies once again in the southern hemisphere. A charged up ionosphere here at nighttime. You can see those blobs south of South America, in the southern Pacific, south of Africa. Those are not your everyday ionospheric anomalies. We cover it daily. Here's the latest image. It's at 10 o'clock universal time. And once again, you can see charged up sections down here where we would not anticipate them, even though it's summer in the southern hemisphere. Next, looking at volcanoes, to see Kluchevskoy is still erupting. It's producing a 22,000-foot plume of ash. Suwanosejima, 6,000-foot ash plume above that caldera. Kadavar now back on the list. Flight level 060 as it explodes. Reported eruption at Sinabung, Popocatépetl exploding, flight level 200. That's a 20,000-foot ash plume. Revenador and Sabancaya both exploding. The Ecuadorian volcano producing a 14,000-foot ash plume, and the Peruvian one producing a 27,000-foot ash plume. Please don't pole vault the caldera. We need the views on YouTube. Next, looking at the earthquakes of the past 24 hours to see the largest. Probably this 5.6, or is it this one? Yep, it's a 5.6 near a three-way plate boundary. in a very desolate part of the world, by the way. The extreme South Atlantic. It's a deep quake, too. And then, let's see, what is that all about? Nearly 2 hours later, we see a deep quake. After a time of quiescence there, we see a deep quake then in Argentina. Here's another deep quake. Also in Argentina. That one coming in about 40 minutes later. So a little bit of activity down there. Otherwise, a lull in earthquakes. And again, the continued earthquake drought, especially of 7, 8, and 9 magnitude quakes, continues. Here's a deep quake in Fiji. A deep quake at Vanuatu. So a series of deep quakes. No large quakes, though. There's a Caribbean deep quake at Puerto Rico. Shout out to Peter Schiff if you watch the content. Please share on your social media. Next thing we're looking at is the low pressure winds. Yes. So we're looking at the geographic South Pole here, folks. And the 10 hectopascal winds are the low pressure winds. They have to be interpolated by a computer to get these patterns, to get the overall 10 hectopascal winds. So that's on nullschool.net, by the way. And check out what's going on in the northern hemisphere. We've got a double rotation, as this has not turned into a single coherent rotation yet, despite it being winter in the northern hemisphere. The 10 hectopascal winds. Now this doesn't have very much effect on your weather. It's more of a measurement of global trends. And let's just go back to the jet stream here. We don't want to spend too much time on this. And check out the extreme meridional jet stream flow here in the northern hemisphere. You got this area over here that's pretty concentrated, normal looking jet stream. And then you've got this area over here, which is total chaos. And anyway, here are the jet streams of the Western world. Shout out to our viewers from the Western Hemisphere. Leave us a comment. Tell us who your smash hole of the week is. And here are the jet streams of the Eastern world. Shout out to our viewers on this side of the globe. Tell your friends, foes, science noobs, and science pros about the content. If you're viewing from China, Taiwan, Hong Kong, Tibet, or any place in the Middle East, leave us a comment. Next, looking at the lightning mapper to see there's nothing to really show, so we'll just move on to lightningmaps.org, a real-time lightning map. Yeah, it's the real-time lightning map at lightningmaps.org. I use it when I hear thunder. There's the current state of affairs of where the lightning is striking on the planet. Here's the U.S. Doppler Radar as we're going into value-added services. We've got some heavy snow there over southeastern Idaho especially, as well as northern Utah, and some crazy ice storm there over south central Canada. And now I'm going to stop talking in a stilted fashion. Major low pressure systems here over the North Pacific. Let's advance this to tomorrow on the GFS forecast. There's where the GFS forecast anticipates pressure cells to be at 12 noon tomorrow. And we're talking local time here. Local time, 12 noon, 5 p.m. universal time. Next, looking at the cloud layer over the U.S. As it's too dark to see it with the visible satellite, we use the 3.2 nanometer radiation satellite instead. Here's what's going on in the water vapor. And we've got some likely cosmic ray flux lines going across the screen here. Check it out. Some baked out images there. It's phosphenes in the form of artifacts on your data. It's artifacts, folks. It's not because there's an alien spaceship in the form of a giant wire in between the satellite and you. It's not an alien spaceship. It's called artifacts. And let's zoom in on the Great Salt Lake. Just for the fun of it. We don't often view this portion of the view. But there you can see that dry mass of air sweeping through southern Utah. About to collide with the Rockies. And it'll be making some clear skies for the southern Rockies. Once that dry air gets there, chances are there are clear skies overhead in that portion of the country. We've actually moved into the end of the video, folks. It's time for me to vanish and show you the colorized magnetogram at ultra high res to show you zero sunspots. We're not even going to show you high res. We're just going to show you that res. Zero sunspots, no really organized areas of magnetic activity. Here's the intensity gram. Again, zero sunspots. We've got a couple more videos of the sun in full animated glory. A regular feature here at the Smash News Network. Here's 304 angstroms. Again, lots of filaments in between the Earth and the Sun. We could see more coronal mass ejections on the way. We'll keep an eye on it for you. And when I say ion, well, the pun is entirely intentional. It's the most amazing, most incredible, most fascinating star that you've ever seen in your life, okay? Okay? It's an utterly amazing, crazy coronal hole-filled sunspot-producing coronal mass-ejecting star, okay? We've got coronal holes forming in a triangle shape like this. An indication that Frito-Lay and Doritos are trying to take over the solar system. Don't eat too many Doritos, folks. They got all kinds of ingredients that are very bad for you. Okay? It's that good. Okay? Dr. Fauci is a fraud. Okay? So please give me praise for keeping Fauci on the payroll. Okay? Anyway, I've been your host, Dan, a.k.a. SMASho. Thanks again for tuning in. Remember, stare at the sun, don't drink, no matter how much the government drives you to drink. And if you do drink, don't drive. And since it'll never be now again, may that solar wind be at your back.